Hello there, friends and neighbors. I'm going to now show you how to run a one-way ANOVA, or analysis of variance, using RCommander. This is what we find with Real Data Homework 12. So let's see, first I'm going to load up R. You double click on your R icon, doesn't matter which. Mine is set to automatically load RCommander and EasyR. If yours is not set to automatically load, then at the command line prompt where you see this caret symbol, you're going to have to type library RCommander, exactly like this. Watch one of the previous videos or the written documentation that I've shared to make sure that you do that correctly. Once you've got that open, you go Tools, Load RCommander Plugins, and you choose the EasyR plugin. Again, mine is set to automatically load, so that doesn't work. Then you click OK, and it will want to restart, and you let it restart, and that's that. Okay, so that being done, I've now got the data set open. We're going to use two data files for this assignment, and I'm going to start with the real data from this class. Okay. So go into my class, go down to whichever week we're talking about. In this case, this is the last week of the quarter. Okay, and go into the unit we're talking about. This is Unit 12, and go into the real data homework for 12. Okay, and you click on it, and the first thing it's going to give you is the option to choose who your team members are going to be. Make sure that you decide on this before you start the assignment. Click their names and click continue. I'm going to do it by myself because it's just a demonstration, so click continue. Alright, so now here I am. It says, of course, the instructions. This is where the video will be after I'm done with it. And it says here's the data file. So that's the first thing I'm going to do is download that data file, save link as. And I have already saved it, so I'm not going to do that again. Similarly, the test scores is what we're going to need for the second half. So click on that, save link as, and that's how we do it. Alright, and here's a complete written example of how to solve this. Moving right along to the first question. We are going to test our hypothesis that there's no relationship between major and exercise because all population means are equal. We will work with the two variables major simple and exercise. Now, your variables may differ from one quarter to the next, and of course the numbers are definitely going to differ from one quarter to the next because these are real data and they change every quarter. But the steps that we follow are exactly the same every single time. Okay, so first I've got R open. Now I'm going to File, Import Data, Read Text Data. That's how we get into data files. I'm going to go find the file. The first one I'll load, I'll call it Classy, I guess. Doesn't matter. And I click OK. And it's data from Stat Survey. So I have got all my data files saved here. There it is, data from Stat Survey. Click Open, and I'm ready to rock. So we're going to run a one-way ANOVA, but the first part we always need is the descriptive statistics. So I'm going to get the average, the sample mean exercise level, number of days exercised, split out by major simple. So let's do that. Statistical analysis, continuous variables, numerical summaries. Then my variable that I'm interested in is exercise, and I'm going to summarize by groups. I'm going to summarize by major simple. And I click OK. And again, OK. And here are my means and standard deviations, 5-number summary, and sample size. All I want is the means, standard deviations, and sample sizes. So I'm going to copy these. Okay, so it's 4.538. Standard deviation, oh, that's too many. I'm going to get rid of some of those decimal places. 3.86. Sample size of 13. 6.6, 10.46. And sample size of 10. 9.26. All I'm doing is copying the numbers right out of the table. 22.67 and 19. Well, 136.3. I'm rounding everything to 2 decimal places to be on the safe side. 198.19. 3. 94.5. 180.34. 94.5, 180.34, and then finally 4. And then I click Submit, and it's going to tell me I am perfectly correct. Now, this is going to be not highlighted in green, it's highlighted in yellow, and that's not for any reason that matters to you. If all your check marks are green, then it's green and it's done. Like I said, this part doesn't matter. Why? It happens to be because I chose 19 points for this assignment, for this question. It's an odd number, it's a little peculiar. Anyway, moving right along. In a real results section, this is where your descriptive stats would go. Next, I'm going to upload a graph. Well, what kind of graph is appropriate? There are a number of options. You can do a bar graph for each group separately. You can do box plots that are separated by group. Or you can do, actually those are the most important ones, those are the most appropriate ones. Well, it turns out that when you run the analysis in R, it automatically will give you the graph. But you can produce the graph yourself. Graphs and tables. Let's say we want a box plot. So I'm going to go to box plot and choose the variable exercise. The grouping variable would be major simple. So major simple. And then remember to change your, if you use a box plot, remember to change the outliers to be 1.5 IQR, that last option. Then you click OK. And here's the graph. And then if you're using Windows or Mac, you can right-click on it, and it will let you choose Save As. I'm not doing that. I'm using Linux, so I don't have that option. But I did save the graphs already before making this video. Here's a bar graph that you'll automatically get when you run the ANOVA, and here is a box plot. I'm going to save the box plot. Save As, and just go upload that file. So I've already done that. And again, here's a bar graph that you'll get. Either one of these would be considered perfectly appropriate. So for the question, that's how you answer the question. You browse, go find the file, wherever you saved it. Maybe you paste it into a Word document, that's also appropriate. And find whatever you named it as. Here I've got an example of a bar graph, I've got an example of a box plot, and then you just upload that question. You upload that assignment to the question. Okay. And submit. Okay, that question's answered. It's going to tell you it's wrong, but that's only because I need to look at it myself.